Good morning, children. Welcome to your chemistry online class. I hope all of you are fine and I hope you are doing your works and all those things. And in last class, we discussed about the classification of the alcohol, phenols, and ethers. In today's class, we are going to deal about the nomenclature of alcohols, phenols, and ethers. Similar to our haloalkanes and haloarenes, they also having two names, that is common name and IUPAC name. So let's learn that. Similar to haloalkanes and haloarenes, there are different methods to write the nomenclature of or the name of alcohols. Those are the common name and IUPAC name. As similar to our haloalkanes and haloarenes, first we'll check the nomenclature of alcohols. So the common name of an alcohol derived from the common name of the alkyl group and in adding the word alcohol to it. For example, if you check here, you can see that CH3OH. So this CH3 group is methyl and OH. We have to add alcohol. So it is methyl alcohol. For example, if it is C2, we can do here. If it is C2H5 OH, then we can call it as this methyl group, hence we can call it as ethyl alcohol. Similarly, propyl alcohol, butyl alcohol, like it will go. Then if this meth, eth root words, I hope you know that if there is only one carbon, that is meth, 2 eth, 3 prop, 4 but, like that it will go. This is about the common name, but we are following most probably the IUPAC name. So for writing the IUPAC name of alcohol, there are several steps. So it is derived from the alkane from which the alcohol derived. The name will come. For example, instead of this alkane E will replaced by the suffix ol. So here you can see an example. And similar to our haloalkenes, we have to find out the position of substituents by the numbers, and we have to find, first step is we have to find out the longest carbon chain, that is parent carbon chain, and from one end we can count, and the hydroxyl group should get the least number, similar to our haloalkanes. Here you can see an example, and the position of OH group we have to give, and the position I have to give by the numerals, and last we have to add the ol. If there are two hydroxyl group, we have to write di, tri, like that we have to write. It has to give the prefix. So if you do with an example, it will be clear. Here you can see, first we have to count number of carbon atom. So there are two carbon atom, so that will be ethine. So we have to write, first we have to write ethine, then which all the position the hydroxyl group will be there. We have to give that numericals. So if we count here, the first carbon atom on hydroxyl group is there, and the second carbon atom on hydroxyl group is there. So we can call it as ethane 1, 2. So two hydroxyl groups are there, so di. So the name will be ethine 1,2-diol. And here you can see some more examples. It is contain only one carbon atom and hydroxyl group, so it is a methanol. We can call it as a common name is methyl alcohol. If you count here 1, 2, 3, so propane. So propane, we have to remove that E. Instead of that, we have to add the position of hydroxyl group here. It is attached to the first carbon, so we can call it as propan 1-ol. What about this one? Here you can see 1, 2, 3 carbon atoms are there, so it is a propan. In second position there is hydroxyl group, so it is propan 2-ol. The last E of that propane have to remove. Instead of that, we have to add the all. So the prefix should be the alkane parent carbon chain and the number, then suffix will be our all, alcohols all. Here you can see some more examples. If there are three hydroxyl group, its common name is glycerol. And how will be the name? The name will be propan 1, 2, 3 triol. Similarly, you can check the examples. That is about the aliphatic alcohols, that is chain alcohols. Then what about cyclic alcohols? Cyclic alcohols have the given the prefix cyclo. So the prefix cyclo and considering the hydroxyl group attached to the C1. So if you check here, the suffix will be cyclo, then prefix will be all. For example, if you check this ring, how many carbons are there? Count from here 1, 2, 3, 4, 5, 6. So it is a hexane. So it is a hexanol because hexane E we have to remove and we have to add all. So we have to add the cyclo in as prefix, that is cyclohexanol. Then if you check here in the second position there is another constituent is there, that is a methyl group. So you have to give the name 2-methyl cyclopentanol. It is a pentane. Why? Because 1, 2, 3, 4, 5. It is contained, the ring contain only 5 carbon. So it is a pentanol. So we can call it as a 2-methyl cyclopentanol. First we have to find out how many carbons are there. And parent is pentane, then their hydroxyl group is there, so pentanol. And if any other substituent is there, we have to give the name to the position of that substituent and its name.